Hello, in this video, we will look at problem solving using recursion. If you think recursively, you can solve many problems using recursion. So let's look at this problem of drinking coffee. We write this function, drink coffee from this cup. If cup is not empty, we're going to invoke this function, take one sip. Continue to drink the rest of the cup by invoking drink coffee cup. In this function, the best condition is cup is empty. If it's empty, that's over. If it's not empty, we continue by invoking the function recursively. So for all the recursive functions, you always have this stopping condition that is the best case. When the best case is true, the function stops, returns. Otherwise, we're going to reduce the problem to a smaller problem using the same approach. Let's look at another example here. This is n print ln, it's print n lines. So we have this times, specifies how many times this message is printed. If times is greater than or equal to 1, so you're going to print at least one time now. The rest, you're going to continue to print this message, but now the number of times is reduced, times minus 1. So again, this is the best case, times greater than or equal to 1, and the reduction to invoke the function recursively, and you see this argument is now smaller. So you continue to invoke it eventually, and this will converge to the best case. Time is going to be equal to 0. Let's look at another example here. We have done a lot of programming already using loops. We can solve all of these problems now using recursion. Recursion does not have any explicit loops. So, but this is happening is using the recursive call continuously. So that is, in effect, it's a loop, but you don't use the loop construct. So let's look at this palindrome. We have done this using loops. So we test the both ends of the string. So if they match, then we continue to test the both ends in the substring. So that's the idea. Using recursion, so this is the same idea now. We tested the both ends. If they match, now we reduce the problem to the smaller problem by invoking the same function again. So this is palindrome, and here is the string. So this is the best case. If both sides don't match, so this is the first one, s bracket 0 not equal to s, the last one is the length of the string minus 1. So that's the index. So if they don't match, this is return true is the size. Okay, if this length is less than or equal to 1, so you have a single character or empty, so that is over. So this is a palindrome, return true right away. If in this case here, if the first character is not equal to the last one. So they don't match. It's not a palindrome. Else, we're going to reduce the problem to the subproblem. So S dot substring and 1, and here is S dot size minus 2. So we get this substring now. This is the many characters starting from this 1, index 1. So the problem of finding if a string is a palindrome now can be solved using recursion. There's a small problem in this solution. It's not really efficient. Every time you invoke is palindrome, you create the substring. So this is a new substring, a new object. We can improve it in the next video. See you on the next video.